Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to our product development series with the Shredder, also known as the Reclaimer. It is extremely hot in here. I have my fan on the lowest setting and the window open, so you can hear a little bit of background noise, but not that much. So last video, we were able to get kind of a rough idea of the stand. I'm going to have to look at this a little bit more off of stream, off of recording, because I think we need to adjust a few things here and there. So I'll have to look at that a little bit more at that point. So that way I can, get it exactly right. But I'm not seeing exactly what I'm gonna do on stream here. I mean, it looks very, very strange. Obviously, I think that these should go down in size. Maybe drop it to some 2-inch plate, 2-inch by 1/8-inch plate. So let's see there. So let's drop this to 2-inch, 2-inch by 2-inch. Let's see what that looks like. But now, whether or not we'll even have room for the bolt heads is another story. For basically for the nuts. So on this, most likely the bolts will come from the bottom, and you'll tighten the nuts up here on top. And basically you'll have a counter bore in the bottom for the bolts to come through if you're doing it on a plate. So if you're doing it on a piece of plywood, you'd have a counter bore on the bottom with some bolts going through the bottom and some nuts on the top. So my idea is basically to have a piece of plywood. If you're going to do manual, which is like a manual breaker bar, you basically bolt this guy as you see here. You put the bucket underneath, you bolt it to a floorboard here. You put it on the floor, and you stand on the piece of plywood close to here, and you wrench on this end here and use a lot of your weight to get it to do what you want it to do. Shouldn't require that much weight, and obviously, as I said before, I modeled it upside down, so we'll fix that later to flip it. We don't really need to do that much now, but that's basically my idea. So let me show that so we could show people what that looks like. So basically, you have the board here, and then you have a piece of board sticking out here, and then you stand on it. So let's see. So if I were to stand on it, I have my tape measure here. So if I were, I would probably lead with my leading foot forward, and I would be in line with the breaker bar. So let's say that my foot, and that's my lead foot. I feel more comfortable with having my right foot forward for some reason. So, but let's say that my lead foot is standing on the like right next to this edge here. So that means that I have basically two, like a hip width apart. So maybe let's say 12 inches apart, and I think I'm pretty natural here. So let's see. So we're gonna need about 29 inches of board, maybe 2.5 feet of board. 2.5 feet. That's 6 inches. So that's 30 inches of board. Okay, so pretty much. And probably 1/2 inch and so I said it was 2 feet wide, right? Which are basically a size 12 inches wide. So I'm going to say 12 inches wide plus an additional 12 inches. So from here to here, let's say, plus 12 inches. This is 7 inches, so that's 19 inches. So let's say here we go this way. Oops. 19 inches. Okay? And then I said 30 inches plus this. 30 inches plus 9 inches, that's 39 inches. So 39 inches here. Okay, and then that's our piece of plywood. So then let's do that, and then piece of plywood, 3/8 of an inch, let's say, that's 0.325. I'd probably go half inch piece of plywood. So a half-inch piece of plywood. Let's see, what do we have? Stop eating stuff, Tiger. Let's see, do we have some plywood? That's weird. Let's just do wood. There we go. So there you get the idea. Plywood. I won't put the bolt heads in it. I mean, you get it. Basically, you lay these things down on top and then a Sharpie, and you just... What you could do is you could hot glue this thing down so it doesn't move, or use double back tape or whatever, and then mark it. Or hold it down with your hand, mark it. Or just put a dot and drill it there, and then do a counterbore on the backside for the carriage bolt or whatever to go in there. So, plywood floorboard concept. So let's put that bad boy in there and show you guys kind of what I'm talking about here. So this is kind of originally, this is probably how I would do it instead of having it tabled. I mean, it depends on how much I'm doing of it. But let's say that, and let's say that. So basically this is how I would do it. That's 12 inches. Yep. So basically that's how I would do it, is I have it in that corner, and basically I have my feet spread apart, and I'm just going to yank on that, piece there. So as long as this doesn't fold upwards when I'm stepping on it, well, probably what will happen is I'll put it here, and then that's probably where my right foot would be. So maybe it's actually from probably this inside. So 30 inches plus this, 30, so that's 32 inches. Oops. Right. So that's more what I'm thinking there. So this is probably how I would do it. So there you go. There's your kind of floorboard. It's going to hold this thing down. You have your bucket underneath. When you're done with it, you can put it up on a table and still use this as a regular table, you know, as a tabletop or something. And then when you need it, you pick this machine up, you put it on the ground, on a piece of concrete or whatever. You stand right here, you stand over here, and you just wrench on it. I mean, obviously, if you're in, like, for example, precious plastics, and you're in a metal container, you could have some sort of plate with some nuts as standoffs and weld it to the floor, and weld the nuts to the plate and bolt this down to the nuts of the plate, so if you ever need to remove it, you can remove it. I mean, that's another option. And, you know, if you're super into it, I mean, you could obviously drill into concrete and set some bolts in there, concrete some bolts in there, or concrete some nuts in there and bolt it down with the concrete and then use that to crank on it if you're going to do it manually. Obviously, if you're going to do it automatic, you don't even need to bolt this thing down on the floor. You just have it sit there, you put your bucket underneath, and you just run it, right? So that's another thing that you could do as well. So, for example, you wouldn't even need this. But this is how I would do it, and this is probably how I'm going to do it from the get-go. Is I'm going to make the stand, I'm going to bolt it down with some carriage bolts onto this piece of plywood here, and then I'm going to step on it here with my foot forward, and then have a big 2 foot long or 3 foot long, I can't remember what I needed. I can't remember if it's 2 feet or 3 feet, probably 3 feet. I think a standard breaker bar is probably about 2, standard breaker bar is probably about 2 feet, so. And then I'm just going to yank on it, and it's, you know, now it's not going to move, it's just going to be relative to where my feet are, and it's on just a cheap piece of plywood, you know. I could even ask one of my friends I know could easily just give me a piece of this plywood 1/2 inch thick and rip it and then put carriage bolts in it. And then you stand on it and you crank on this thing and put some pellets in here. And obviously that's if, you have the sheet, the sheet metal housing, blah, 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 all that other stuff. So that's kind of the idea of the full housing. Oh, I think I shortened the piece of plywood, so it's going to shorten. There we go. So that's basically what it is, and at the end you end up with a 32 inch by 19 inch piece of plywood, right? And it's something that you could stand on. It'll hold it to the floor. You don't have to worry about this thing flopping around. And as long as it doesn't bottom out, I mean, you're basically going to be pulling on these pieces here. So as long as this stays pretty good, then you should be okay. So we'll see. And also I could do some analysis maybe later where I put a foot here and I put a foot here. And then that's where I have forces down or constrained. It's basically constrained. Constrained in 2 patches. And I'm clamping on this and then I'm pulling on this thing. What happens? How is this thing going to fold? Is it going to survive, etc. Which, maybe we could do that right now. Send it to the cloud and see that. So basically what I'm going to do is let's go onto this plywood and let's go here, and then basically what I'm going to do is I'm going to have a foot about here, sorry there's crickets outside here. So I'm just going to draw a box here. So this is 7 inch. And obviously I want to project this. So this is 7 inches this way. 7 inches by, I don't know. And let's look this way. This is 9 inches that way. Okay, so basically my foot's going to go about here, let's say. So let's say I have, this is my foot, and then I have some line of some certain length here. Let's say 1 inch away. And my foot is 4.5 inches wide by 12. 4.5 inches wide by 12. 12 by 4.5. And then 30 inches minus 12. Minus 12 is 24. So about 6 inches apart here. About 6 inches apart. And then the other foot. So this is 12 by 4.5, let's say. That's about good. I could split it to maybe 7, maybe almost 8 inches apart. Cool, 8 inches apart. I like it. All right, so now what we're going to do is we're going to bump this up just 0.001. Same material, and now it's just stuck up just a little bit. You can't even see it. So now when we save this, save it, and we're going to go to the stand assembly. We're going to update it. And what we're going to do, go into simulation. We're going to do static stress. And we're going to put materials, make sure everything's good. Steel, 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 front bracket. I mean, it says it's hardened steel, but that's fine. It doesn't really matter. And let's say that I put a torque of my full weight here. So let's say structural load force moment. I'm going to put it here. Or I mean, you could put it there. Yeah, it's basically there. Okay, so let's say my whole weight times 2 feet. So let's see, foot pounds, pounds per foot. So 2 times my weight So let's say I'm 100 and right now I'm at 160 pounds, 65 pounds. Well, it depends. All clothes 170. So that's 340, right? So let's say 340 foot-pounds. Okay. And we have a constraint here and a constraint here. So now basically what we're going to do, call contacts, and let's just say 10 millimeters. And let's make sure everything is Gucci here. It doesn't look like it is. Fully fixed, everything's fully fixed. Oh, we might need to change this to something else. Because it's a non-linear material, basically. I mean, we just kind of say it's plastic. So let's see what its properties say it is. Shh, tiger. Let's see what it says. Birch. Birch yield is 1 to the negative 5 megapascals. Plastic. Oops. Okay, so yeah, this is way high. So it's pretty soft. Well, as far as the yield strength. Can I do non-linear? Non-linear static stress. Weird. I mean, we go back. Let's just say it's plastic. We go back later and change the material. It's fine. So let's just say that this is plastic here. Plastic. And we want to go into the settings here, and we're going to go mesh, base size mesh. And let's do this 1, 2, 3. And then we're gonna solve. Oops. Actually, this, I think that let's just try this. Actually, sorry, adaptive mesh. Let's try adaptive mesh. Let's do a low percentage of adaptive mesh. Oops. And I think we're good. Let's go ahead and start solving. And solve. Okay, so now that that's doing what that's supposed to be doing, that's going to do it on the cloud. Add to Autodesk. We'll see how that works. What else do we need? Okay, so let's go ahead and start on the next component. So let's go here, and basically we're going to do new folder, hopper. Now let's go ahead and go in here, and what we're going to do, oops, shredder, and we're going to go down here to the shredder assembly, copy into hopper, copy. Oh, we don't need to copy it, actually. Sorry, don't need to do that. Delete that. Do you want to delete the shredder? Yeah. Okay, basically we want to drop it in because we are doing the hopper assembly. So let's say here, we're going to go in here, we're going to say hopper assembly. And we're going to say here, this is going to be a hopper sidewall. Let's say we get rid of this, get rid of this. We'll call this hopper. And basically this is sheet metal. But pretty much what it's going to do is, if we look here, pretty much is it's going to have it's going to go like this. It's going to go up, like, it's going to go here and then up. Tiger, stop. So it's going to go here and then up. And then pretty much what it's going to have is it's going to have a little 45 earlet here, so it can bolt on to the other piece, and then a 45 earlet here. I don't even know if it even needs to bolt on. We could probably just have it bent upwards and then have it meet in such a way, and we could see if we need to fold it. What I would like it to be is thin enough sheet metal where I could just kind of maybe even buy a little finger brake, small short little finger brake, and then be able to just bend it here. And then maybe some way of cutting it, maybe a small short shear or some sort of maybe like a 3-in-1 or some type of something like that. So let's see. So hopper wall, basically what we need is I need to draw the side, and then this will probably be welded onto the same sort of flat piece, just like this piece here. So pretty much what I'm going to do is, what says some have interference? Shouldn't be that big of an issue. Stand, and pretty much what I'm going to do is I'm going to drop the mount in here. Oh, wait. And then pretty much that's what I'm going to go off of. It's going to use the same exact mount. And then it bolts here, and then we're going to weld the hop, and then pretty much we're going to weld the hopper on top and punch these 2 holes here. Or we punch 2 holes first, weld the hopper on, and then punch the holes back again from the backside. So basically what we're going to do is we're going to do that. And then the sheet's going to come off here at the start, and then it's going to open up at a certain way, and again at the top it could be a maximum of 12 inches. I don't want it to go into a box sideways. So basically we're going to have a 12 by 12 opening. Maybe a 12 by 12 by 12, and then we could have the sheets sitting on top of the shredder. Inside the box. If we ship it with the box, the hopper could be inside the box. So basically this can be a maximum of 12 inches here and here, so this could be a maximum of 12 inches. Oops. And these both have to be equal length. And this angle between here and here, or let's say this angle between here and here, is whatever. This angle also has to be the same as this one. So now they're the same length, 12 inch, and also this from here to here can't be longer. Wait. Oh, wait a second. Delete that, delete that. From here to here cannot be longer than 12 inches. But another thing, in actuality, this is going to be 3D, right? Because it's kicking back out. And I would like it to be a 12 inch by 12 inch opening. So let's go ahead and actually we want to do this. So pretty much what's going to happen is they are going to go. But see, this is where it gets difficult, because now it's like it's basically going out and back at the same time. right? So what I could do is I could do a big sheet. So how would I do this? I would have a path and then sweep a profile along a path. Probably is what I would do. So I'll have a path down here and I'll sweep it along this path, right? That's probably what I would do. And have it go up. So can we do like a 3D something? Or maybe it goes to some sort of point somewhere. That's a good question. I've avoided this for a long time now. I finally have to do it. Let's see how the simulation's going. It might fail because we have some interlying stuff. So, I mean, here it looks good. Let's not this. It's 12 inch, 12 inch. Oops. Oops. Yeah, so it's approximately 104. 104 inches, and then this thing is 12 inches tall. And it kicks back. So basically it has to kick back. So we have the machine itself is 6 inches, I think, on the outside, right? The machine itself is... Ooh, centimeters. Let's go back to design. 6 inches on the outside. Plus, I want to open up to 12 inch by 12 inch on the top. So you can fit some pretty big stuff in there. So 12 inch. Yeah, that's a decent size hopper. So let's say 12 inch by 12 inch. So half of it here, half of it here. So it's got to kick out 3 inches. Tiger, stop. So let's say here, if we're going to project these guys, it's got to go this way. 3 inches. Basically like that. So I guess we could do that here, but it's not gonna get the taper angle that we need. So basically what we're gonna have to do is cut it, but that's fine. So let's do that. Oh wait, gonna do this here. Okay, so now we're gonna draw a line from here up, and then basically we're gonna do a box, and this is probably gonna be, let's see, steel gauge to thickness. Hey man. I think my cat need to go to the bathroom or something. Okay, so let's see here. Sheet metal thickness. Let's say 16 gauge. 16 gauge should be fine. 16 gauge steel should be okay. I mean, basically the limit is how much can I cut, you know, or bend on a handmade something. So let's say here, distance from this to this is 0.060, and the distance from this to this is 0.060. Okay, and then obviously there's a radius here. Okay, then pretty much what I need to do is look at the distance from here to here and look at the XYZ delta, negative 2.757. Okay, and then we're going to do a negative 2.757, negative 2.757. But it's the other way. Okay, and then pretty much what we're going to do is we're going to redefine sketch plane here. Oops. Gonna move this back, or move this forward. .757, and then we're going to go back here and we're going to redefine sketch plane here, and then we're going to extrude from here all the way down to 12 inches basically. What? Negative 12. Negative 12 inches. Then we're going to create another sketch. Doesn't really matter here. We're going to project here, here, and this. And then we're going to close. And then we're going to basically cut everything else. But first we're going to project this and project this. So now when we grab this, we're going to contain everything, and now we have some sections to cut. But obviously the issue here is that, ooh, what happened here? Let me delete it. But anyways, we need to have this join with here, so we're gonna have to do some hand drawing, because how we're gonna get this guy to join in here, because it's gonna come up, basically kind of close up, not necessarily join, because it doesn't need to have it just needs to be relatively solid. I mean, I would really like to bolt it so it's really strong, but I mean, I don't necessarily have to do that, so we will look into further designs. Oh, it looks like it might be finished. Maybe. Oh, here it goes. You better not crash. Come on. Okay, so where's the minimum load? Oh, minimum load's in there. That's fine. Okay, so basically let's go into results. Where's that? Where's the thing for the where it's exaggerated? They used to have a little thing over here. Very strange. Anyways, it's super exaggerated there. And for some reason, it won't let me do anything with it. I don't know why. But looks like we're okay, so. Just everything here looks in the blue. Obviously this is with plastic, so if it's plastic I'm sure wood would work. So you should be okay using this guy. We're all 8+ in the wood area. And then if you guys are wondering what I did, no one let me see the mesh either. So basically that adaptive mesh control is pretty much, it'll run a simulation normally, and then it will see where it needs more resolution, where the high stresses are high, and it will actually make the mesh smaller in that area. So that's what the adaptive mesh control is. And I actually lost an internship because I wasn't able to answer that question at this previous job, and I happen to actually work there now for a different person. Whether or not I would have had more fun then or now is a different question. I don't know, but because before it was going to be building test stands kind of like this all the time, which I don't know, might be funner than what I'm doing now. But anyways, yeah, so that's basically it for this video. We'll go back into the hopper and finish that up, and then probably go to working on the motor next. So maybe maybe 2 more videos for the hopper, and then another video for the motor. So we have another video tomorrow, Friday, and then probably by the end of next week we'll have everything done, and then we should see our sample probably that weekend. So we'll see, and assemble that sample that weekend. Alright, so thank you guys for watching. If you liked this video, please subscribe for more videos like it, and I'll see you guys next video. Take it easy. Peace.